In this video, you will learn about how to determine the chloride content in the given water sample using Mohr's method. The steps are quite simple. Take 20 ml of unknown water sample which you want to test. It can be tap water, seawater, or the sample your lab instructor gives you. Then pour 2-3 drops of potassium chromate, which is an indicator. Now just titrate the solution by silver nitrate solution. Repeat these steps up to 3 times to get precise reading of chloride content. So let's start. The chemicals needed are N/50 AgNO3 solution, distilled water, and freshly prepared potassium chromate solution. The apparatus needed are conical flask, beaker, measuring cylinder, burette with its stand, and a wash bottle. Pour 20 ml of given water sample in the measuring cylinder. That's done. Pour this into the flask carefully. Our water supply has a very poor amount of chloride ions, so we are adding external chloride ions. So taking 5 ml of NaCl solution in this cylinder, we'll pour this into the flask too. Now fill the burette with silver nitrate solution up to 0 marking and remove the funnel from the burette head. Now drop 2 to 4 drops of freshly prepared potassium chromate carefully into the flask. Put the beaker now under the burette's dropper. But let's see what's going to happen now as titration occurs. So the chloride ions are sitting in the form of NaCl in the solution. But then comes the drops of silver nitrate into the flask. The AgNO3 molecules will react with the NaCl molecules and would make AgCl and NaNO3. This AgCl has something special. It is a milky substance that keeps forming until the whole chloride ions are eaten up. So let's see this happen. Open the stopcock of the burette. We are doing the titration slowly to let you notice the color change. This insoluble milky substance is AgCl. This marks that there are no more chloride ions left in the solution. So what happens next? The AgNO3 molecules keep coming inside the flask from the burette, and these need someone to react with. These will react with the chromate ions now and will frequently form silver chromate, which is a red-brown precipitate. As soon as this color appears, stop the titration and note down the reading from the burette scale. Repeat the process 2 more times to get a precise value. Fill up the burette again. And mix 5 ml of NaCl in 20 ml water sample. Pour 2 to 4 drops of potassium chromate into the flask and titrate it again with the AgNO3 solution. If 2 of the readings match, then we will take that reading as our final reading for calculations. This time the reading is 6.8 ml. Doing this for the last time. So washing off the flask, we'll fill the burette again up to 0. Well, sometimes what happens is that the liquid goes higher than the 0 marking. This is not bad and it can happen very often. That's what happened here too. We'll put the beaker below and we'll take out the excess solution and pour it back into the container. Okay, now pour 2 to 4 drops into the flask and titrate the solution. This color remarks we have almost reached the end of the titration, but we still haven't got that brick red color. So titrate a little bit more but slowly and carefully. The reading here was 7.3 ml, which is the same as the first reading. Now wash off every apparatus as we are heading towards blank titration, which needs the distilled water. Well, why should we do blank titration? Why is it needed? A blank titration is that process in which the analyte is not present in the solution to be tested. It is done to check for possible sources of errors. For example, the water sample contains many impurities which can eat up the AgNO3 molecules. This may give you an inaccurate reading. So as to avoid this, we subtract the reading of blank titration from the general titrations reading. This minifies the chances of inaccurate readings. This is the color we were looking for. Repeating this again. The reading is 0.8. Doing this for the last time. So as we have the values now, we can calculate the chloride content in the water sample. The procedure is given in the PDF attached to the description below. Thanks for watching.